In this video, we're going to develop a way of finding out the arc length of a function from A to B. So we want to find out this length here from A all the way to B. And the way we're going to do that is we're going to cut the distance from A to B into n number of strips. So this here is your x0, x1, x2, all the way to xn. So this is xn minus 1. But because we want to look at one particular strip, we want to look at one particular strip. So we've got to call it a different name, xk minus 1, and this here can be xk. This here can be xk. So let's just zoom into this one here. So when you zoom into this particular point, it will look like this. It will look like this. So this here is xk minus 1, xk. So so this point here is really f of xk. This point here is f of xk minus 1. Okay. So this height here is delta y. This length here is delta x. So if you want to know this length here, we're going to call this length here LK, because there are lots of strips. Hang on. There are lots of strips. So this length here, the straight line that joins this bit to this bit here, we're going to call it LK. The length that joins this bit here, the straight line that joins this to this, we're going to call it L1. Okay, so the length that joins from here straight to here, we're going to call it Ln. Okay, so this particular line here, we're going to call it Lk. Well, the length here, Lk, is given by us using Pythagoras. So this going to be this squared, and then plus delta y squared. So it's really us using Pythagoras. So this length here is given by this. Okay, and then so the whole length, so the total arc length from the total arc length from here all the way to here would be us summing up all the capital L's. So remember, from the straight line that joins from here to here, this here is K1. L1. So it's really us summing up all the straight lines. So it's us. So this is L2, L3, and so on. So we are summing up all the straight lines. Okay. So hang on. So it's us summing up all the straight lines. So the arc length is approximately the sum of all the capital L's. Okay, it's approximately. So later on we're going to make n go to infinity, meaning delta x going to 0. So when you make n head towards infinity, then delta x will automatically head towards 0. Well, later on we're going to make delta n head towards infinity. So as delta n heads towards infinity, then the arc length will be precisely equal to something. Okay. So at the moment the arc length is approximately the sum of all the straight lines. Okay. So this is what we've got earlier. This is what we had earlier up here. Okay. So up here, this is the diagonal length, and then the arc length is approximately the sum of all those diagonal lengths. Well, all the diagonal lengths is really us summing up all the diagonal lengths. So that really takes us to this. Now this is where it gets complicated, because from here we're going to use the mean value theorem to take us from this thing here to this thing here. Okay. Yeah, I'll explain this in the next video. But by using the mean value theorem, well, at the moment we don't want this delta y. We will we want to get rid of this delta y and replace it with this thing here. But in order to do that, we need the mean value theorem, which I will elaborate more in the next video. But roughly speaking, remember from the mean value theorem, we've done this in the past before. The mean value theorem, remember there's a c somewhere in between here and here. There exists a c here. I will explain in the next video. Okay.